Science isn't just facts, it's stories. Carbon is the element that won't quit. It's in your bones, your coffee, your phone, and that diamond you hope to afford. It can be soft enough to write poetry or hard enough to cut steel. It's the same atom, just different personality. So how did one element become the ultimate shapeshifter of the universe? Welcome to Tireless Knowledge, where science gets just the right amount of attitude. Today, we're talking about the sixth element on the periodic table, carbon, symbol C, atomic number 6. The reason you exist and the reason your barbecue tastes amazing. Carbon isn't weird because it glows or explodes. It's weird because everything depends on it. Without it, there's no DNA, no plastic, no TikToks, no tacos. Civilization simply evaporates. Let's start with why carbon bonds, like it's collecting friends for an atomic reunion. Carbon has 4 bonding spots. Chemists call that tetravalent. That means it can hold hands with 4 different atoms at once. Hydrogen, oxygen, nitrogen, other carbons, carbon doesn't discriminate. That's why it builds long chains, rings, and lattices, the backbone of organic chemistry. If chemistry had a dating app, carbon would break it. Carbon's many moods show up as allotropes, different forms of the same element. Graphite, diamond, graphene, amorphous carbon, it's a full personality lineup. Take graphite, the stuff in pencils. Each carbon atom bonds with 3 others in a flat honeycomb sheet. Those sheets slide easily over one another, which is why you can literally draw with atoms. Then there's diamond. Every atom locked in a tight 3-dimensional network, 4 bonds per carbon. That geometry makes it the hardest natural material known. Same element that writes breakup poetry also survives the breakup. Change the structure, change the story. Graphene is the futuristic cousin, a single layer of graphite, 1 atom thick. It's lighter than air, yet stronger than steel, and it conducts electricity better than copper. In theory, it could make flexible phones and quantum chips. In practice, we still haven't figured out how to make it cheaply enough to brag about it. Then there's amorphous carbon, the messy version. Charcoal, soot, and carbon black, atoms thrown together with no order at all. They don't shine like diamond or glide like graphite, but they keep your grill hot and your tires tough. And we can't skip the fullerenes, hollow soccer ball-shaped cages discovered in the 1980s. They launched nanotechnology and still inspire ideas for drug delivery and molecular machines. Carbon's imagination knows no bounds. Every carbon atom on Earth began its life inside a star. Deep in stellar furnaces, 3 helium atoms fuse into carbon-12. When those stars die, they scatter their carbon across the galaxy. That dust becomes planets, oceans, and eventually you. When someone calls you a star, they're technically right. You're made of recycled stardust. Carbon even comes with siblings called isotopes. Carbon-12 is the stable, everyday kind. Carbon-13 is slightly heavier and used to track chemical pathways in biology. And carbon-14 is radioactive, the one scientists use to date fossils. It decays at a steady rate, acting like a built-in atomic stopwatch. Even when carbon is dying, it's still helping us tell the story of life. Carbon is the hero and villain of our age. Burning fossil fuels releases ancient carbon stored underground. It mixes with oxygen to form carbon dioxide, CO2, the main greenhouse gas warming our planet. That doesn't make carbon evil, just efficient. It's humans who keep inviting it to the wrong parties. Handled properly, it's brilliant. Activated carbon purifies air and water thanks to billions of microscopic pores. Carbon fiber builds airplanes, bikes, and race cars, light but insanely strong. Medicines, fuels, plastics, all born from carbon's restless bonding habits. Roughly 80% of known compounds on Earth are carbon-based. That's not coincidence, that's dominance. Every living thing on this planet runs on carbon chemistry. Your body, plants, microbes, all powered by molecules made from carbon, hydrogen, oxygen, and nitrogen. Carbon sits at the center because it forms stable bonds at room temperature and loves variety. It can make single, double, or triple bonds. It can twist itself into chains, rings, or cages. Silicon might look similar on the periodic table, but it simply can't compete. Carbon is molecular jazz. Silicon is elevator music. In your body, carbon builds amino acids, sugars, fats, and DNA. When you breathe out, you release carbon dioxide, proof that your chemistry is still online. Every atom of carbon in you has probably passed through a forest, an ocean, or a dinosaur. It never dies, it just keeps changing costumes. A diamond the size of a paperclip contains 100 billion carbon atoms. Burn it in pure oxygen and it disappears. No ash, no trace, just invisible gas. That's chemistry's magic trick. Matter never truly dies, it just changes form. Plants absorb carbon dioxide during photosynthesis, turning it into sugars. Animals eat the plants, breathe out carbon dioxide, and the cycle repeats. That's the carbon cycle, the planet's breath. Burning fossil fuels compresses that million-year rhythm into a human lifetime. The chemistry hasn't changed, only the tempo. Carbon powers technology too. Graphite moderates nuclear reactors. Carbon composites shield spacecraft from re-entry heat. In batteries, it stores charge and moves electrons. Civilization literally runs on carbon's willingness to connect. Every diamond ring, every candle flame, every breath, they're all carbon telling the same story. It's the handwriting of the cosmos, linking the living and the dead, the stars and the soil, pencils and promises. Carbon isn't just element number 6. It's the storyteller of the universe. So next time you draw, breathe, or light a candle, remember, you're watching carbon perform its eternal act, turning life into light and back again. Thanks for watching Tireless Knowledge, where science never gets tired of being fascinating. Subscribe if you want to keep chasing the elements that make the universe tick.